The star Betelgeuse, a red supergiant located in the Orion constellation, has fascinated astronomers and sky viewers alike for a long time due to its enormous size and luminosity. If Betelgeuse were positioned where our Sun is, it would extend all the way to the orbit of Jupiter, displaying its vast dimensions. Despite the fact that it weighs approximately 642 years from Earth, it is one of the most brilliant stars visible to the naked eye. In recent times, however, Betelgeuse has shown some unusual activity, including sudden dimming and brightening cycles, which many scientists believe may indicate that the star is nearing the end of its life. Recently, world-renowned physicist Brian Cox made a groundbreaking declaration that Betelgeuse is on the verge of a devastating explosion that is anticipated to occur within the next 2 weeks. This event, known as a supernova, will mark the end of Betelgeuse's existence, but will present an extraordinary opportunity for scientists to investigate one of the universe's strongest and most spectacular phenomena. As a massive star nearing its end, Betelgeuse is a red supergiant, one of the largest and most massive types of stars in the universe. It has been under observation for centuries, but its recent erratic changes in brightness have sparked speculation that it may soon go supernova. When a star like Betelgeuse reaches the end of its life, its core collapses under the immense pressure of its own gravity, causing an enormous explosion that ejects a tremendous amount of energy, radiation, and stellar material into space. Betelgeuse's imminent explosion is expected to be a Type II supernova, a particular kind of stellar explosion that occurs when the core of a massive star commences with this core collapse. The release of neutrinos and radiation creates a shock wave that explodes and disintegrates the star. This will be so intense that it may even be visible from Earth without the need for telescopes, possibly even outshining the moon in the night sky for several weeks or months, while a similar occurrence would normally be destructive if it occurred. Closer to Earth, the distance between Betelgeuse and our planet, around 642 light-years, implies that, despite the explosion being dramatic and visible, it won't pose any risk to life on Earth. However, this occasion promises to radically alter our perception of supernovae and cosmic phenomena. A supernova is one of the most energetic universe-wide events, releasing more energy in just a few seconds than our Sun will over its entire lifespan. Betelgeuse's explosion will not only be a stunning celestial display, but also an important opportunity for scientists who study these events. They are eager to keep an eye on this rare occurrence from the beginning, making use of various ground-based and space-based telescopes, such as the Hubble Space Telescope and the James Webb Space Telescope, JWST, to collect as much data as possible. When Betelgeuse explodes, it will emit a vast range of radiation, ranging from visible light to gamma rays. One of the most critical aspects of the supernova will be the flood of neutrinos, elusive subatomic particles that rarely interact with matter. Supernova-derived neutrinos can arrive on Earth earlier than the light from the explosion itself due to their ability to pass through nearly everything without being affected. Observatories like Japan's Super Kamiokande Ice Cube and the Kandy Neutrino Observatory in Antarctica are preparing to detect these neutrinos, giving scientists an early start in observing the final moments of Betelgeuse. Additionally, the explosion will offer crucial insights into the formation of heavy elements. When stars go supernova, they forge and release elements like iron, gold, silver, and uranium, materials essential to our understanding of life. Studying Betelgeuse's supernova will allow researchers to observe this element creation process in real time, which is essential for comprehending how planets and the universe's chemistry come together. Although Betelgeuse's supernova is not expected to have harmful consequences for Earth, it will likely interact with our planet's atmosphere and magnetic field in fascinating ways. The energy burst from the explosion, particularly the arrival of charged particles and cosmic rays, could generate stronger auroras, expanding the regions in which the northern and southern lights are visible. While these cosmic rays could potentially disrupt satellite communications and some earthly technologies. Only minor disruptions are anticipated. One of the most exciting aspects of Betelgeuse's explosion is that it will be visible to any individual on Earth, not only experienced astronomers, with high-tech equipment. For weeks or even months, Betelgeuse is expected to be the brightest object in the night sky, possibly even visible during the daytime. This spectacle will not only captivate the scientific community, but also engage stargazers and the general public, sparking renewed interest in astronomy and the cosmos. Astronomers have long speculated about the death of Betelgeuse, but Brian Cox's recent statement accentuates the urgency of the situation. Over the next few weeks, observatories around the world are preparing to study each stage of the supernova, and the data collected will be priceless, potentially transforming our understanding of stellar evolution, core collapse supernova, and the distribution of cosmic matter. Betelgeuse's supernova will also provide a rare chance to improve our models of the distances between stars. Being relatively close to Earth, it offers an unparalleled chance to observe how energy from such an explosion travels through space. By studying the light and radiation from the supernova as it interacts with the interstellar medium, the gas and dust that exist between stars, astronomers will gain a clearer picture of the universe's scale. This event will also provide a golden opportunity to investigate dark matter and how it may influence supernovae. Dark matter, the enigmatic substance that makes up about 85% of the universe's mass, does not emit or absorb light, making it difficult to detect. However, observing how light and matter behave around Betelgeuse's explosion might provide indirect hints about the role dark matter plays in shaping the universe. Betelgeuse's supernova will also take us closer to understanding the life cycle of stars, especially how massive stars play a role in the creation of the elements necessary for life. Supernova are the primary cosmic events responsible for spreading heavy elements throughout the universe, elements that eventually form new stars, planets, and even life. By learning from Betelgeuse, scientists will obtain crucial data on how these elements are forged and distributed. The cultural significance of Betelgeuse's explosion is profound. For millennia, humans have looked to the stars for direction, motivation, and wonder. The disappearance of one of the most visible stars in the night sky will elicit philosophical considerations regarding the transient nature of the universe. Betelgeuse has been a constant fixture in the constellation Orion for as long as humanity has observed the stars, and its absence will serve as a powerful reminder of how fleeting celestial things are. In some cultures, such events have been seen as omens or signs of cosmic change. Betelgeuse's explosion may stir feelings of awe, fear, and wonder as individuals from all walks of life observe a star's death. This extraordinary event will likely rekindle curiosity about space, astronomy, and exploration, attracting more people to the pursuit of knowledge pertaining to the universe. Amateur astronomers are already preparing for the event, as modern technology allows virtually anyone with a telescope or camera to keep track of the supernova and record it. This democratization of science will unite people across the globe, all watching and documenting the same cosmic event from their unique vantage points. Betelgeuse's explosion is not only a singular astronomical event, but also a stepping stone for future space exploration. The knowledge gained from the supernova will affect how we study other stars, especially as missions take us further into space to other planets and stars. Understanding the life cycles of stars and the dynamics of supernovae is crucial as humanity looks to expand its presence beyond Earth. The explosion will also rekindle enthusiasm for the search for extraterrestrial life. Supernovae play a vital role in distributing the elements essential for life, like carbon and oxygen, across the universe. The universe, through research, Betelgeuse's explosion, scientists can improve their comprehension of how the ingredients for life might spread to other systems of planets and possibly ignite life elsewhere in the universe. The impending explosion of Betelgeuse is looking like it will be one of the most significant astronomical events in our time. Its supernova will provide a wealth of scientific data, enhance our knowledge of the universe, and captivate people all over the world. Though Betelgeuse's death will mark the end of a giant star, it will also symbolize the ongoing cycle of creation and destruction that governs the cosmos, a reminder that from death, new stars, planets, and even life could form. As we await this monumental event, the world will be gazing at the sky at night, preparing for the occasion when one of the most potent forces in the universe explodes into view. For researchers and stargazers, Betelgeuse's final act will be nothing short of awe-inspiring. As Betelgeuse approaches the final stage of its life, one of the more speculative yet intriguing possibilities surrounding its potential is its impending eruption to shed light on some of the universe's most intriguing mysteries: dark matter and energy. These elusive forces are believed to account for the vast majority of the mass and energy of the universe, but they remain poorly understood. Some scientists believe that supernovae, like the one anticipated from Betelgeuse, may hold the key to unlocking some of these mysteries. Supernovae release an extraordinary amount of energy and radiation, and some researchers believe these mighty forces might interact with dark matter in ways we can observe and study. One fascinating hypothesis is that dark matter exists in the form of massive, weakly interacting particles, WIMPs. If WIMPs do exist, their interaction with the energy generated by Betelgeuse's supernova could provide crucial clues about their nature. Such a discovery would be revolutionary, offering the first direct evidence of a mysterious phenomenon known as dark matter that has confounded scientists for decades. Similarly, the explosion of Betelgeuse could offer insights into the nature of dark energy, the mysterious force that drives the accelerated expansion of the universe. By studying how light and energy behave during the supernova, scientists may gather crucial information about how these cosmic events impact the universe's expansion and their potential connection to dark energy. The upcoming explosion of Betelgeuse offers a unique perspective on the life cycle of massive stars, which play a crucial role in the cosmic ecosystem. Red supergiants, like Betelgeuse, are rare, making their study essential for understanding stellar evolution. These stars form from clouds of gas and dust that collapse under gravity, eventually igniting nuclear fusion. As they exhaust their hydrogen fuel, their cores fuse, they expand dramatically, shedding their outer layers. This mass, carried by powerful solar winds, contributes to the enrichment of the interstellar medium, paving the way for the emergence of brand-new stars. When Betelgeuse explodes, it will not only offer insights into its own life cycle, but also function as a cosmic laboratory for studying the conditions under which stars live and die. Researchers will keep a close eye on the explosion to ascertain whether a black hole or a neutron star forms. The fundamental nature of this remnant will provide valuable information about the physical processes that govern the final stages of stellar evolution. The dynamics of the explosion itself will also provide a wealth of information. The shock wave produced by the supernova will destroy the surrounding area, heating the gas and dust around it and causing it to glow brightly. This emitted light will offer astronomers clues about the components made during the explosion, such as iron, nickel, and other heavy elements. By analyzing the spectral signatures of these elements, scientists will be able to determine their abundance and distribution, enhancing our understanding of how these elements propagate through space and contribute to the emergence of new stars and planetary systems. Another area of study is the possibility of gravitational wave detection. As the core collapses and the supernova opens up, it may generate ripples in space-time that are observable by observatories like LIGO and Virgo. Gravitational waves carry information about the dynamics of the event, potentially offering new insights into the physics of supernovae and black hole formation. Betelgeuse's explosion could also be a driving force for advancements in astronomy technology. The anticipated surge of observational data will likely push the limits of current astronomical instruments, potentially leading to breakthroughs in imaging technology, data processing, and real-time analysis. These innovations could benefit a wide range of astrophysical research that goes beyond the supernova. Public engagement will play a crucial role in Betelgeuse's supernova, fostering an appreciation of wonder and curiosity about the universe. Educational programs, outreach initiatives, and citizen science projects will use this event to inspire the next generation of astronomers and physicists. Schools and universities may organize viewing parties, lectures, and discussions that emphasize the importance of understanding the cosmos and our place within it. As we prepare for this monumental event, excitement is building in the scientific community and among enthusiastic amateurs. The anticipation surrounding Betelgeuse's supernova encapsulates humanity's desire to explore the unknown, challenge our understanding of the universe, and unite us in our pursuit of knowledge. The death of a star becomes a profound reminder of the cycle of creation and destruction that defines the universe and urges us to reflect on our own existence and the cosmos beyond comprehension.